Okay, today we want to look at some of the different types of graphics that are used when we are doing statistical analysis. And like we looked at last time, we looked at the histogram, and that's definitely a graph that people use. But there are actually many other types of graphs out there that you can use for statistical analysis. So we're just going to go through some of the different ones here. One of the main things I want you to focus on, though, as we go through this section, is that there are graphs that are used with quantitative data, and there are graphs that are used with qualitative data. So we're going to first look at some that are used with quantitative data. The histogram was one, but there are actually many other types of graphs. And depending on what you want to highlight of the data, which one you want to use, you might like some over the others, depending on what kind of data set you have. The first one we have here is called a frequency polygon. And it's basically this line segment form of your histogram. So they basically took your bars that you normally have with a histogram, and they put little dots kind of on the top of the bars, in the middle of each of the bars, like kind of at the class midpoint, and then they just drew a line that connected all the dots that they put up there. One thing to note whenever you're looking at a frequency polygon too is the data starts at 0, 0 when you first start drawing your line segment, and then at the very end, after your last class, you'll go back down to the axis, the x-axis. So you'll sink back down right there. Okay. So this basically is just the exact same graph almost as a histogram. It's just as a line segment instead of a histogram with bars. Okay. Next we have an ogive plot. This one has a kind of a weird name there, but it actually represents a cumulative frequency over time. So it's like adding up as you go. If you remember the cumulative frequency distribution, okay, it's basically that in a graphical form, okay. And this might be useful for if you're doing like something where you want to show the total is growing, like maybe if you're fundraising for your company and you're showing like the money that y'all get, maybe each hour, or you could even do like, your goals, you show the money is growing toward your goal at the end. However you want to represent that. You want to have something where it's like the total is important. Maybe if you're looking at total rainfall for like a year, you could actually have that being, growing to the total amount of rain over the course of the year. So there's an ogive plot basically representing a total frequency or cumulative frequencies. Next is a scatter plot. And we are actually going to talk about scatter plot in the next little section as well. So we'll be going over this in 2.4. But it's basically you have paired data, like X and Y data, that you put on a grid. You pair it up, and then you're seeing if there's some kind of relationship between the two paired data. So if you look at this data right here, we have chirps per minute. So like we have on the x-axis cricket chirps, and then we have temperature outside. So they basically paired up these. And maybe, why would you be caring about this? Maybe you're a biologist or you work in a park or something. Anybody that's in biology or animal science might be interested in this, seeing about the temperature's effect on animals. Well, if you look here, do you see a trend that's happening between chirps and temperature? Well, yeah. If you see here, like, whenever there's a few chirps, the temperature is lower. But whenever you have like a lot of chirps, like 1,200 chirps, the temperature is higher. 1,200, a little bit less than 1,200, the temperature is high. So it looks like as temperature rises, cricket chirps rises. So crickets chirp more when it's warmer outside. So you're basically seeing if there's a statistical relationship between two variables. And the thing about this is you can actually pair up any two data with each other. It doesn't have to be something that makes the most sense. You can find correlations between any two random pieces of information. There's a graph online where somebody has paired up like the number of Nicolas Cage movies and then like the number of drownings per year or something, and show that there's a correlation between those two. Which those two you wouldn't think have any bearing on each other. So it doesn't necessarily mean like they're connected at all, really. But you can actually see if there's a correlation between them. Any two paired data. It don't even matter what it is. Okay. Now, this next one right here is a time series graph. And this one basically has the x-axis. you have it be in some kind of unit of time. So it can be years. This one's years. You could also have it be like hours of the day or months. And then this one's an interesting one about drive-in movie theaters. I got this one from your textbook, but they show that, in 87 there was like over 2,000 drive-in movie theaters, and then as you go down or as you go to the right, just a couple of years later, there's almost 1,000, like maybe a little less than 1,000 actually, movie theaters. So it like drops so significantly, and I always ask students like, what do you think the reason is for this drop? And there's a lot of speculation of what happened here. Some people said that, maybe that's the year VHS came out, or, those tapes. If you remember back in the day, we had those tapes. You had to rewind. But VHS maybe came out around this time. Some people also speculated that maybe like those digital theaters, the air-conditioned ones or whatever, the more modern ones, I guess, they maybe were on the rise. So less people are going to the drive-in movie theater that you had sit in your car and watch a movie. So there's a lot of reasons why this probably drop-off occurs. And you can probably think about some places where you've seen time series graphs just on like the news. So think about if you see a weather alert for the day. Usually they'll have like hours of the day, like maybe 8 a.m., 9 a.m., 10 a.m., and then they'll have the temperature throughout the day. Like, temperature gets warmer and warmer as you move throughout the day. That would be a time series graph as well. You could also talk about like stock market trends over the years, like kind of like this line segment here, show how the stock market, rises and falls, or a particular stock in general rises or falls as the years go by. You could also do that. That's a time series graph that you might have seen somewhere. Okay. The next example here is a dot plot. And the dot plot basically represents a dot for each data value. So this is actually one of two plots I'm going to show here where you can actually get back your original data set. So if you look here above 24, see how the number 24 has two little dots above it? That means there were two actresses that were age 24 in this data set. So you can actually reconstruct your whole entire data set. So there was two 24s, there was 4 25s, and then 26 there's 4 of them. So all the way up to 32 there was 2 people. There was 32. So you can actually get back your entire data set with a dot plot. And similar to that, there's a stem and leaf plot. A stem and leaf plot is also representing your data with like breaking it down. You have tens over here, and then you have these leaves, which kind of represent, in this case, the units or the ones place. But you have a stem and leaves. It shows how your data's spread out, basically, right here. So you can see, like, this is also the actress ages one. You can see, like, the actresses that win the awards, there's more of them in the very beginning. And then you might be wondering, like, how do they get these numbers in the weird way they are? So if you look here on the line with 5, there's 5, and then there's a 0 and a 4. Well, that's the age 50. So there was an actress that was age 50, and there was an actress that was age 54. So there's two actresses here on this line. And then 4, there's a 40-year-old, and then see how there's a 11111? That means there's 5 41-year-olds in the data that won Academy Awards or whatever. So, and you can still tell the common things about the graph, like the data. You can see here that most actresses win when they're in their 20s and 30s. So, and then it kind of dips off after that. So, this one right here, the tail's in the right, so it would be a right skew kind of data set right here. Okay? But yeah, stem and leaf plot, both are good for summarizing large sets of quantitative data, and you can get back the original data as well as learning about the distribution of the data. So, they're actually really powerful tools for plotting data. Now, that's all the ones I have for quantitative data, probably the most popular ones. And like I said, there's more out there than just those. We want to turn our attention now to look for some that are used with qualitative data. So there are a few that I have for qualitative data. This first one right here is a Pareto chart. Okay, a Pareto chart, it has bars. You may see it looks similar to a histogram, but the one thing about it is, it's used with qualitative data, not quantitative. Histogram is quantitative, but Pareto chart is used for qualitative data. So that's one difference. But the other difference is that the bars are in order from like greatest to least. So you have them in their order. And it's great for showing like the frequencies like in connection to each other, like which one's the most. So maybe you're trying to make cuts. This looks like maybe a company. They have like a marketing division, international calling division, access charges. Maybe you're trying to make some cuts in your company, and you're trying to say, okay, which one, has the greatest usage or whatever you want to say. Marketing is larger than, maybe you see the two that are close. Cramming and marketing are kind of close to each other. Well, cramming is larger, so maybe you can make a cut there and cut it back so it's not taking up as much money or as much resources. So this Pareto chart is really good for seeing, like, especially the ones that are close to each other, seeing which one's the most and the least. Next, we have a pie chart. And a pie chart, most everybody's seen a pie chart before, but you have basically slices of the pie that are in proportion to how much frequency is in that particular class. So this is kind of that same chart as before with the slamming, marketing, cramming. And the thing about this one is, a pie chart is nice, but sometimes it's harder to see, like, maybe which one of the slices, especially when you get to some of the slices that are the same size, about the same size, it's hard to see which one may be bigger. Now, you can look at the numbers and tell, like, okay, well, access charges is more than operator services. Even though the pie slices look about the same, the access charges are more. Now, if you are trying to emphasize the size of the different categories, it's probably better to use the Pareto chart instead of the pie chart. But pie chart is a nice, lovely little breakdown. Most, Excel, there's a lot of spreadsheets that can easily generate pie charts for you. So they are nice to use because they're very easy to generate. And then the last one that I have here for the quantitative data is the bar graph. The bar graph, most people have seen it as well. The only difference is it has gaps in it from the histogram. Like, the histogram, it has no gaps or spaces, but the bar graph does have gaps in it. You can see the data is kind of spread out here. And also, with the bar graph, you can kind of do some interesting things with it. On this one right here, for each of the years, they actually have done male and female amounts for each year. So, male and female, that's qualitative data. And that's another difference between bar graph and a histogram is bar graph is usually qualitative and a histogram is quantitative. So that's another difference. But besides the spacing, we have male and female data paired up for each of the years. So the bar graph you can do some very interesting things with that you might not be able to do with some of the other graphics, like the pie chart and the Pareto chart. So it's very interesting. And those are just examples of some of the graphs. There's tons of other graphical techniques out there in statistics, more being developed every day. So these are definitely not all of them, but these are probably the more common ones that you'll encounter in your life and throughout the course.